Okay, now this is the way you can do the reverse engineering. Then see for this. Now you tell me. Okay, now like this. Now first easy thing is how many on the right hand side? 1, 2, 3, 4. Now 4 poles on the right hand side means there are 4 sign changes, right? So there are 4 sign changes. Clear? 4 sign changes, system is unstable. One point is completed. Okay. Now easy point you have to be identified first everywhere. Right. Total 1, 2, 3, 4, 5, 6. So the total number of poles are 6. Therefore, order of the characteristic equation is 6. Okay, that is also clear. Now, yes, non-repeated symmetrical poles are existing or not? Yes, these are the symmetrical poles. These are the symmetrical poles, but which is not repeated, no? Here -1 again, here +1 again, no, it is no repetition. So there is no repetition, therefore, one time the row of zeros occur. One time the row of zeros occur. Now, the sign changes existing, how many sign changes total? 4 sign changes existing. In that 4 sign changes, now see here, now let us assume this is one pole and there exists a symmetrical pole here, and this is one pole and there exists a symmetrical pole here. Now 2 poles is on the right hand side, then there exists a symmetrical pole on the left hand side. Am I not? 2 poles on the right hand side, then there exists a symmetrical pole on the left hand side, which means that now the 2 poles on the right hand side and its corresponding 2 poles is on the symmetrical on the left hand side, which means that now the sign changes existing below ROZ. But how many sign changes total? Out of 4 sign changes, 2 sign changes. This is because this is 2 pole. 1, 2. Let us take. Okay. Now these are the 2 symmetrical poles. 1 and 2. Therefore, now these 2 sign changes are existing. Now 2 sign changes existing below ROZ. 2 sign changes existing below ROZ, and again there are 2 sign changes, but there is no symmetricity for those 2. Therefore, now again the 2 sign changes, existing below ROZ, and remaining 2 sign changes. Now because total 4, out of 4, 2 sign changes below ROZ and 2 sign changes above ROZ. So out of 4, now 2 is below ROZ and 2 is above ROZ. Clear or not? Yes. Next. Now, how many symmetrical poles with respect to origin? Now the number of symmetrical poles with respect to origin, 1, 2, 3, 4. Therefore, the power of the auxiliary equation is the power of the auxiliary equation. Auxiliary equation power is 4. The number of symmetrical poles with respect to origin will give the power of the auxiliary equation. Non-repeated symmetrical poles with respect to origin is nothing but the number of times the row of zeros occur. Note down. Okay. Now see here. So total 6 poles. Total number of poles are 6. Therefore, the order is 6. Highest power in the characteristic equation is 6. Now see here, what I am saying, in all the previous questions, non-repeated symmetrical poles. Non-repeated symmetrical poles. In all the previous questions you just observed. Now here in the explain, plus J1 minus J1. If these two are not available, how many times the row of zeros occur? Only one time. But here what happened? Repeated. So now how many times it is repeated? 1, 2, 3. Am I right or not? So there are repeated poles with respect to origin. Then that should be the row of zeros. Now how many times the row of zeros occur? 3 times the row of zeros occur here, because now the row of zeros is nothing but the row of zeros here. There are 3 times, because non-repeated symmetrical poles is only one time the row of zeros occur. But the number of repeated symmetrical poles will use the number of times the row of zeros occur. Now this is first time, second time, third time. Okay. Now here 3 times the row of zeros occur, because repeated symmetrical poles. How many? So the 3 poles which are repeated. So this is the 3 times row of zeros occur. Now there is no pole is on the right hand side, therefore no sign change. There is no sign change. But the poles are repeated on the imaginary axis, system is unstable. No sign changes, repeated poles, system is unstable. Right? Now there is no sign changes, therefore there is no need of this particular point. There is no sign changes. Next, now the power of the auxiliary equation. So the number of symmetrical poles with respect to origin. This is 1, 2, 3, 4, 5, 6. Therefore, the power of the auxiliary equation. So the number of symmetrical poles. What is the symmetrical poles? Now this is 1, 2, 3, 4, 5, 6. So the total number of symmetrical poles with respect to origin is 6. Therefore, the power of auxiliary equation is also 6. Clear or not? This is very if this is correct or not, any doubt, then you find the RH tabular form and you can cross check. Okay. And for practice sessions also, now you can do that one also. Okay. Now in your classroom workbook now starts. This is question number 1. Okay. All these are the questions whatever we solved, all are questions itself only. Okay. But now while explaining the concept, therefore I just take those examples. Therefore, that is already our questions. Okay. But in the workbook, I will put a separate questions. Now we'll solve that question. Okay. This is question number 1 in our workbook under the concept of Routh Hurwitz stability criteria. Okay. Now what is that question is? Now in this question, he is given the characteristic equation. Now the question is characteristic equation s power 5 plus 2s power 4 s power 5 plus 2s power 4 plus 3s cube plus 6s square plus 6s square minus 4s minus 8 equal to 0. While looking this characteristic equation without the second thought, you want to say the answer. Now 5, 4, 3, 2, 1, 0, no missing term, but there is a negative sign, negative terms, negative quotients in the characteristic equation. System is 100% unstable. Okay, without doing anything, unstable system. How I can say? Because negative term or missing term will lead to the system instability of beyond order 3. Okay, now this is unstable system, but that is not the question he is asking. What is the question he is asking? Now by giving the characteristic equation, he is asking the number of roots that strictly lies on left hand side of S plane. Number of roots that strictly lies on left hand side of S plane. Options is given 1, 2, 3, D, 0. So these are the options which is given to you. Okay. So this is the question, and by looking this question I can say unstable, but that is the question is number of roots that strictly lies on left hand side of S plane, and these are the options which is given to you. Okay. Now we will try to solve this one by finding the characteristic equation. Now s power 5 odd number of quotients, odd power quotients, 5, 1, 3, minus 4, 0. S power 4, even power quotients, 2, 6, minus 8, 0. Now S cube, 2 into 3, 6, 6 minus 6, 0. 2 into 4, minus 8, 2 into 4, minus 8, minus plus 8, 0. 2 into 4, minus 8 plus 0, 0 and 0, 0. Now one complete row becomes 0. This is the auxiliary equation. Now the auxiliary equation is 2s power 4 plus 6s square minus 8 is equal to 0. Now differentiate the auxiliary equation. dA by ds, which is equal to 8s cube plus 12s plus 0 equals 0. 8s cube plus 12s plus 0. So this is 8, 12, 0, 0. Now see here. Now this is the differentiation of the auxiliary equation. Now this is again s square, 8 into 6, 48, minus 12 into 2, 44. 48 minus 12 into 2, 24, means 24 by 8. 24 divided by 8. So this is nothing but 3. Now 8 into 6, 48 minus 24, 24, 24 by 8, 3. Now 8 into minus 8, minus 64, minus 64, 0, minus 64 by 8, minus 8, 0, 0. Now s power 1, s power 1. Now this is s power 1, which is nothing but 12 into 3, 36, plus minus minus plus 64. Now this is 100, 100 by 3. Now this is 0, 0, 0. Now this is s power 0. Some x into minus 8, minus 8x, 0, this is minus 8. Now this is the first column. Okay, just note down that first. Clear or not? Now this is the first column. Now I'll just write. This is plus 1. This is plus 2. This is plus 8. This is plus 3. This is plus 100 by 3. This is plus 100 by 3. Now this is minus 8. Now see here, positive, 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 negative, sign change system is unstable, but without doing all these things, you are already saying system is unstable, right? Now the question is, total number of poles are 5. Total number of questions are 5. Total number of poles are 5. Now there is how many sign change? Now this is one sign change. Therefore, one pole lies on right hand side of its plane. One pole lies on right hand side of its plane. Therefore, option 1, which is 100% wrong. Now the question is not asking how many poles on the right hand side of its plane. The question is asking number of roots that strictly lies on left hand side of its plane. But most of the students are blindly thinking that now right hand side 1, therefore you go for 1, which is the wrong answer. Understand or not? Therefore, now see here, now one sign change system is unstable. Therefore, one pole is on the right hand side of S plane first. One pole is on the right hand side of S plane first. You put that one sign change, positive, 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 positive. Then this is negative, one sign change. And one more thing also. Now this is the row of zeros occur. How many times? 1 times the row of zeros occur. 1 times the row of zeros occur, and this sign change is below row of 0. Am I not? Now this sign change is below row of 0. What I am saying? What is the concept I am saying? Whenever the sign change is below row of zeros, whenever the sign change occurs below row of zeros, then there exists a symmetrical pole to the right hand sided pole. Then definitely there exists one symmetrical pole here. Okay. Then there exists one symmetrical pole. And one more thing also I am saying, am I not? Now this is the row of zeros occur. Now whenever this row of zeros occur, poles are arranged symmetrically, am I not? Now this is the row of zeros occur, the poles are arranged symmetrically with respect to origin, am I not? Now you can find the roots of this auxiliary equation. Now this is the auxiliary equation, so we can find the roots of those auxiliary equation and we can find the roots. So you find the roots of this auxiliary equation. Now this is nothing but, now the auxiliary equation is 2s power 4 plus 6s square minus 8 equal to 0. Now this 2 is common, s power 4 s square minus 4 equal to 0. So 2, 3, okay, right. Now this is, let us take, this is y square plus 3y minus 4 equal to 0. Am I not? Now let us take, let s square equal to y. Let us take s square equal to y square plus 3y minus 4 equal to 1. Now can I write like this? 4 1 into 4, right? So this is minus 1 minus 3. Y minus 1 into y minus 3. Therefore, this is y square. So y square, and this is minus 3y, and this is minus now this is y into y square, and this is minus 3y, and this is minus y, and this is 3 into 1 3. So we can write like this, right? Now these are the roots, very simple. Y square plus 3y minus 4 equals 0. One root is minus 1 and another root is minus 4. 4 into 1 4, 4 minus, yes, one is 4 and one is 1. Okay, now first you just take down this and we will find the auxiliary equation roots and what happens. And some of you are saying, no sir, finding auxiliary equation, finding the roots, now this is already, then there is a lengthy analysis. No, then without doing this also you can find. This is one solution, but without this also you can find. Now see here, how many times the row of zeros occur? Only one time the row of zeros occur. This is only one time the row of zeros occur. Now only one time the row of zeros occur means definitely the poles are arranged symmetrical with respect to origin or not? Yes, definitely the poles are arranged symmetrical with respect to origin. Now see here. Now the poles are arranged symmetrical. Let us assume this is one pole. One row of zeros. One row of zeros means symmetrical pole with respect to origin on imaginary axis. Okay. Now see here. Now these are the symmetrical poles with respect to origin, and one more question I am also asking. Now see here, 1, 2, 3, 4. Out of total 5 poles, then the 4 poles location is completed or not? Out of total 5 poles, 4 poles location is completed, am I not? Now out of total 5 poles, 4 pole location is completed. Now where is one more pole? Now you tell me, where is one more pole? Now that one more pole is on the right hand side? No. Why? Because now only one sign changed, therefore only one pole is on the right hand side, therefore definitely that pole is on the left hand side of S plane, am I not? Definitely that pole is on the left hand side of S plane. Therefore now this is nothing but, now what is the correct answer? The correct answer is the number of roots that strictly lies on the left hand side of S plane is 1 and 2 is strictly on the left hand side of S plane. Therefore option B is correct. Then there is no roots of auxiliary equation. If you want, you can do it. Okay, it's not a problem, but there is no need of doing the auxiliary equation roots, and all these things are not required. This is also very important question. Note down. Okay, but the students are confusing that no sir, row of 0 means this is exactly is on imaginary axis. Don't confuse. If you have any doubt, now how I am writing is one sign change, therefore one fellow is on right hand side, okay, and the sign change is below, therefore there exists a symmetrical, therefore I can get one is on left hand side, full clarity, okay. One row of 0 means definitely the poles are symmetrical with respect to origin on imaginary axis. One row of zeros means poles are only one, means non-repeated poles on imaginary axis. 2, 2, 4. Now out of 5, 4 is completed. Where is 1? It should not be definitely right hand side, it should be on left hand side. Now you have some confusion, that's why we do for the auxiliary equation also, okay, we left no, that will continue. Auxiliary equation. Now 2s power 4 plus 6s square minus 8 equal to 0. Take 2 as a common. S power 4 plus 3s square minus 4 equal to 0. Let us assume s square equal to y. If you assume s square equal to y square plus 3y minus 4 equal to 0. Right? Very simple rule. Now y minus 1 into y plus 4 equal to 0. Therefore, okay, minus 1 into plus 4, okay, minus y and plus 4y. So 3y is sufficient. Now see here you can get very clarity. Y minus 1 equal to 0 means s square minus 1 equal to 0. Now students, very important point here. Now this is s equal to plus or minus 1. S square equal to 1, s equal to plus or minus 1. First you write. Now this is plus 1 and this is minus 1. Is it correct or not? Okay. Now this is plus 1 minus 1 is sufficient. But it will take time. But if you given 1 or 2 marks, then you have to do it. This total is not only tabular and you directly do it. Okay. But anyway, this is you can I will give the clarity purpose. Now y plus 4 equal to 0. Y plus 4 is nothing but s square plus 4 equal to 0. Therefore, s square equal to minus 4. Therefore, s equal to plus or minus j2. So this is s equal to plus or minus j2. Now 1 is plus j2. Another one is minus j2. Clear or not? Now 1 is plus j2. Now another one is minus j2. Now you see here auxiliary equation power. Auxiliary equation power is 4. What is the meaning of that? Auxiliary equation power is 4 means 4 symmetrical poles. 1, 2, 3, 4. Matching. There are 4 symmetrical poles. Am I not? So there are 4 symmetrical poles, but now there is full clarity. Okay. Now this is auxiliary equation roots 4. 4 is completed. 1, 2, 3, 4 completed. Now out of 5, 4 is completed. Now the question is, sir, where is that 1, sir? Where is that 1? Can I write here right hand side? No, it should never be right hand side because only one sign change. One sign change. Okay. Therefore, it should be on the left hand side. The total number of strictly poles lies on the left hand side is 2. This is a 2 marks question which is given in the previous GATE examination. Note down. And in the GATE examination, you don't do this one. Understand or not? You just see this one. Sir, one sign change. Put 1 is on right hand side. Clear? Listen carefully. One sign change. Put is on one right hand side. Okay. And that sign change is below ROZ. Put a symmetrical on the left hand side. Okay. Next. Now one row of zeros. One row of 0 means definitely the symmetrical pole with respect to origin. Definitely the symmetrical pole with respect to origin. With respect to origin, how many symmetrical poles? One row of zeros means one symmetrical pole with respect to origin. Now 1, 2, 3, 4. 4 is completed. Out of 5, 4 is completed. Where is 1? Take a question. Definitely it should not be on the right because only one sign. It would be on the right. 1, 2. Total strictly poles on the left hand side is only 2. Okay. Now clarity. So strictly on the right hand side is 2. Sorry, strictly on the left hand side is 2. Option B is correct. Okay, this is a very important question. Now for 2 marks he is given 2 bits. See the tabular form. From there itself we have an answer for that particular question most of the time. So you have to cleanly identify the tabular form and you observe the tabular form and make a point, and that point should be your answers. Okay, and see the question carefully. He is asking number of poles on the left hand side or right hand side. Okay, now one small example before we solve the another workbook questions. Now g of s, which is equal to 1 by s. Now this is the open loop pole is at origin. Okay, and what is the closed loop pole means? I can write a characteristic equation 1 plus g of s equal to 0, and this is nothing but 1 plus 1 by s equal to 0 and s plus 1 equal to 0 and s equal to minus 1, and this is the closed loop pole minus 1, and closed loop control system is stable. Is it right or not? This is a simple question, you know that. And this is the open loop pole, and open loop control system is marginally stable. That I don't want. I want interested on the closed loop control system stability. Is it right or not? Now my question is, this is the open loop control system marginally stable, and this is the closed loop control system is stable. Here pole is at origin, here pole is at minus 1. Am I not? This is fixed. This is also fixed. This is at origin, this is at minus 1. Now in this particular question, now I just do a small change. Now see here, g of s, same question, g of s, which is equal to k by s. Now where is open loop pole? Same, without any change. This is open loop pole, and where is open loop control system is marginally stable. Now what about the characteristic equation? Now find the characteristic equation. Now the characteristic equation 1 plus g of s equal to 0. Therefore s plus k equal to 0. Therefore s equal to minus k. S plus k equal 0. S equal to minus k. Am I not? Now this is the closed loop pole. Now my question is, when k equal to 1, or when k, first we'll check, when k equal to 0, where is closed loop pole? closed loop pole is at origin and closed loop control system is marginally stable. Now, when k equal to 10, closed loop pole is at -10 and closed loop control system is stable. So what you can understand? Now we can understand that now here the closed loop control system is marginally stable, here the closed loop control system is stable. Am I not? So that closed loop control system stability depends upon the system gain k or not? Yes, because system gain is a system parameter. Am I not? The system gain is a system parameter. Therefore, definitely the closed loop control system stability depends upon system gain k. A very simple question here. Now this is the closed loop pole. Now the closed loop pole which is a function of system gain. Now this is the closed loop pole which is a function of system gain. Therefore, closed loop control system stability is depends upon system gain. Depends upon system gain k. Whereas you take in the open loop control system, now open loop pole is at origin. When k is 0, here is same, k is 1, here is same, k is 2, here is same, k is 100, open loop pole is at origin. So see this one. Now closed loop pole is a function of system gain, whereas open loop pole is independent of system gain. Is it right or not? Open loop pole is independent of system gain and open loop control system stability is also independent of system gain k. Okay. Now anyway, I am not interested in the open loop control system stability. I am interested on the closed loop control system stability. That closed loop control system stability depends upon system gain k. That closed loop pole location is also depends upon system gain k. So when k changes, closed loop pole location changes, stability is also changes. So with respect to closed loop control system stability depends upon the system gain k, and we can classify the closed loop control system stability into different parts. We'll see that. First you note down that. Now with this example, what we can understand, when system gain k changes, closed loop control system stability changes because pole location is a function of system gain k. Is it right or not? So based on that, then now this is the closed loop control system stability. The closed loop control system stability is with respect to based on system gain. Now this closed loop control system stability is classified into two types based on the system gain k. Now one is absolute stability. And another one is conditional stability. One is absolute stability, another one is conditional stability. One is absolute stability, another one is conditional stability. Now the name itself here, it is condition. I will take one example. If k is less than 10, greater than 0, then only the system is stable. If k is greater than 25, then only the system is stable. If k is greater than, less than or equal to 20, greater than or equal to 0, then only the closed loop control system is stable. Now this is for example, here the system is stable for a certain condition. That's why this is called as conditional stability. But here, if the system is stable for all the positive values, is nothing but from 0 to infinity, if the system is stable, then that particular system stability is called as absolute stability. Here the system is stable only for certain range of values of k, then that particular stability is conditional stability. Here the system is stable. Here the system is stable for all the positive values of k. Here the system is stable for all the positive values of k. Then that particular stability is called as absolute stability. Now here the system is stable. Here the system is stable only for certain range of values of k. Here the system is stable only for certain range of values of k. If the system is stable, that particular stability is called as conditional stability. Here the system is stable for all the positive values of k. Now that particular stability is called as absolute stability. In the question he is not mentioned find conditional stability, find absolute stability. That itself we want to identify whether it is a conditional stable system or absolute stable system. Okay, if nothing is given, so far what we are doing, we are assuming that k is all from positive and we are doing absolute stability. If k is only for certain range, that particular stability is called as a conditional stability. Okay, in the question itself we can easily identify a conditional absolute. First you note on this.